All right, hey everybody, welcome to our new lesson about similar triangles. Forgive me, I've been out in the cold, my cheeks are real red, my eyes are watery and all that, but hopefully that won't distract you from learning. All right, do you remember when we were talking about triangles being congruent? We didn't have to figure out that all of the corresponding sides and angles were congruent. We had all these other ways of figuring out that triangles were congruent. Similar triangles, where there are the same shape but different sizes, work the same way. When we're trying to determine the triangles are similar, we don't have to know that all the angles are congruent or that the sides are proportional. Remember, when we're talking about similarity, angles will always be congruent, sides will be proportional. The ratios will be equal. Remember these symbols as well. Congruent, there's our symbol for congruent, here's our symbol for similar. So when we're making similarity statements, we're going to apply this symbol right here. Okay? All right, the first one, the AA similarity postulate. Do you see how AA is going to line up with similar to some of these up here? If two angles of one triangle are congruent to two angles of another triangle, then you know that the two triangles are similar. So in our diagram over here, we know that angle T over here is congruent to angle P. Also, angle R is congruent to angle L. We have two angles of this triangle congruent to two angles of this triangle. We can conclude that those two triangles are congruent for the AA similarity postulate reason, AA. We won't have angle side angle or angle angle side, because if you think about what this says, we would know that two angles are congruent with angle side angle, two angles are congruent with this. We don't need that for similarity statements because all we need are two angles. Why don't we need three? If we know what these two angles are, knowing that all three of these angles in this triangle are going to add up to 180, and same thing is true with this other one. If these two are congruent and these two are congruent, then angle S has to also be congruent to angle M. So that's why we only need two. If you have two angles of a triangle, you actually do know the third angle of the triangle as well. Okay, so AA is one of them. SAS is the other one. If one angle of one triangle is congruent to one angle of another triangle, and the sides including, that phrase is important, the sides including those angles are proportional. In fact, if you're paying attention right now, right over here on the margin, this is important, put a star over here next to this. The sides including are proportional. Then the triangles are similar. So let's look at this example over here. Given that angle B is congruent to angle Y, okay, the sides, are they proportional? Well, let's compare. There's 3 over 6, small to small, the small of the small triangle to the small of the big triangle. How does it compare with the bigger side of the small triangle to the bigger side of this triangle? You always have to make sure that you're comparing corresponding parts when you do so. But yes, because 3 over 6 is congruent to 4 over 8, they are proportional. Then we have included sides, included side angle, included sides, SAS, these are similar. What do we mean by included side? Well, if I changed the diagram so that I still had this angle is congruent, and I had two pairs of proportional sides. 3 over 6 is equal to 4 over 8. But those are not corresponding parts. The angle that is included between 6 and 8, these two sides over here, would be angle X. The side that's included, or the angle that's included between sides of length 3 and length 4 is angle B. So the included sides are the ones that have to be, the included angles have to be the ones that are congruent, included by the two sides. So that's what we mean by that. All right, so back to this, we got angle angle, we got side angle side for similarity theorem. The third one and the final one is the SSS similarity theorems. If the corresponding sides, all three of them, of two triangles are proportional, then the triangles are similar. So make sure when you're checking this out that you go smallest to smallest. 2.5 is the smallest of this triangle, 5 is the smallest of this triangle. 2.5 to 5, how does it compare with the next size? The next one would be 3 and 6, 3 over 6. And then the biggest is 4 of the small triangle, biggest is 8 of the big triangle, 4 over 8. How do those three ratios compare? They are proportional. They are equal to each other. So we can then say, because of a side-side-side similarity theorem, we have similar triangles. That is the lesson. Angle, angle, side, side are the three ways that we can know that we have similar triangles. Let's look at the types of questions. I'll do the first one with you. Tell whether the triangles are similar or not similar. If we can't reach a conclusion, write no conclusion is possible. All right. We have one angle is congruent to another angle, but these are certainly not congruent. But remember, if we know two angles of a triangle, we know the third. So we know that these other angles have to be equal to 58 degrees and 66 degrees. So do we have two angles that are congruent? The answer to that is no, we only have one. So these are not similar. However, on number 2, if we know two angles of a triangle, we know the third. Those are 70 and 60. So check this out. We got 50 degrees, 60 degrees, 70, 50 degrees, 60, and 70. So these are similar because of the angle-angle postulate. Something that's worth noting here, if we applied names to these triangles and we were making a similarity statement, which I will be asking you to do, if we name this triangle ABC, what is it similar to? We have to make sure that the corresponding parts correspond. So angle A corresponds with angle F. Those are the two that are 60 degrees. Angle B is corresponding with E. So triangle ABC corresponds with FED. If you're not careful, you'll mess that up. Okay, go ahead and see if you can answer the rest of these. I've done 3 for you to see that the angle there, but go 4, 5, and 6 on your own and see if you can figure those out. Pause. Okay. Number 4, hopefully you saw there's no conclusion, that we only know that one angle is congruent. We don't know anything about the sides. On number 5, they are not. Those angles are not congruent. Number 6, we have one pair of congruent angles between the little triangle and the big triangle. Are those parallel? That would help us to know we have another. Oh, no, they're not parallel. Okay, that's a right angle because 45 degrees, 90 degrees. That's a right angle. Is this a right angle? Well, we have no way of knowing that. So there's no conclusion can be made here. All right, this group of question involves the sides as well. Clearly we have an angle is congruent with an angle. Do we have the sides that are including that angle being proportional? 6 over 12, does it equal 7 over 14? I believe that it does. So yes, those are similar triangles because of the side-angle-side theorem. Go ahead and see if you can apply angle-angle, side-angle-side, and angle side-side-side to 2 through 6 as well. Give it a shot. Okay, there's answers to 2 and 3. There's 4 and 5. If these two sides are congruent and these two sides are congruent, they have to be, their proportions are the same. So side, angle, side works here. What'd you say for number 6? Okay, for the little triangle and the big triangle, they share angle D. So, yes, side, angle, side. Okay, here's the most important part of these two sections is solving for the variable. This is the most difficult type of question right here where we have these overlapping triangles. When you have overlapping triangles, listen to me and do this. Redraw the triangles. Until you get really good at this, redraw the triangles. Now first, are the triangles similar? Well, yes. Oh, when we redraw them, be careful. The big triangle, AB, is equal to 8. Oh, hold on. What I was trying to say is when we make this big side of here, this is 8 and 4, so 8 plus 4 will equal 12. The length of AB is 12. Then AS is equal to 10. AC is going to equal 10 and Y, 10 plus Y. Okay? Now, do we have similar triangles? Well, thanks to having a shared angle, angle A, those are congruent, and then we have parallel lines, so we have corresponding angles that are congruent. Yes, we absolutely have, for the same reason the other angle would be congruent. So we have similar triangles. Now we can set up a proportion. The key is we have to be consistent. If I go the smaller side, all right, just have to have corresponding parts. 8 and 12 correspond, so I can go 8 over 12 equals 10 over 10 plus y. The order of that is what matters. You should be able to solve that proportion. To make life easier, 8 over 12, that creates our scale factor 2 to 3. So you don't have to use 8 over 12 in your equation. You can simply write 2 over 3 equals 10 over 10 plus y and solve that. You should know how to solve it. Do it. Like really, go solve it. You should have gotten that y is equal to 5. Okay? Example 2, we've got to add a little bit something to this equation, or this one diagram. It got left off here. Let this be y plus 3, this be y minus 2. Now we have options here. 12 over 6, 12 over 18, and then 16 over 24 have the same ratio. They are proportional. So the scale factor from either of those is 2 to 3. You can use 12 over 18 or 16 over 24 to solve, but smaller numbers are easy to work with. Use that scale factor, 2 over 3, to line up 2 over 3 is smaller to bigger, smaller triangle to bigger triangle. So y minus 2 is on the smaller triangle, y plus 3 is a bigger triangle. There is your equation to solve. And you should know how to solve that. The answer is 12. Okay? So that's how this works. You have to be careful on numbers 7 and 11 in particular because of the overlapping parts. But see if you can solve for x and or y. Okay, so if I don't see work on your page, I will know that you just copied the answers. Okay? Here's answers to 7, 8, 9, 10. Did you appropriately add x plus 7 and x minus 1 when you did number 11? If you didn't, there's no way to get 5, but that's the answer. Okay, get some rest. Ask me questions if you have them. I'll talk to you soon. Bye.